This is a Guinness surge unit, and it's basically a unit that has an ultrasonic transducer in it. So you place your glass of Guinness into the tray, which has a small amount of water in it for coupling, and you press the button, and this is the wrong type of Guinness, and it surges it, and a cloud of very fine bubbles come up and create a thick, very fine frothy head on top, and that's actually worked quite well this time. The last time it just went everywhere. So let's try it with something different. So now let's try it with a heavily carbonated, well, this is blackthorn dark fruit cider. I'm not sure exactly how many apples it's actually seen in its life, but adult alcopop. So this is heavily carbonated, really not suitable for the task. Right, yeah. See, that's not ideal. I'm not sure exactly how much my cider is going to be left once this is finished settling down, but that's what happens when you try surging a very heavily carbonated drink. So we've seen it working, now let's take it to bits. Things worthy of note: it seems quite well sealed with rubber grommets, but I'm guessing that's because this thing is designed to get wet ultimately, because drinks can froth over. When you plug it in, and this power supply is a 16.5 volt AC power supply, 1 amp output, very heavy, it's a traditional power supply. And when you plug it in, this little light here lights once, twice, and then it stays on the third time. So that suggests a little microcontroller initializing inside the unit. Which would make sense, because that would control probably the ultrasonic energy and also the time delay from this simple button. It's got rubber feet in the bottom, which I'm guessing are hiding screws. Ooh, blimey. I thought they were going to be stuck on. They are hiding screws. Oh, let's get them all out then. Oh, that one's stiff. Oh. Odd feet. You know, that is quite odd for a start, that they've got such a... that they're going in so deep. I guess maybe that's so they can... and that one came out easy. Okay, so they can actually seal it properly. So let's see how easy this comes to bits. Oh, this just barely reaches in. So the reason I got this in the first place, I was in a pub with some friends and we ordered Guinness, and the Guinness thing at the bar was the sort of standard sort of beer tap sort of illuminated display thing. But behind it was just one of these, and it just looked like a map behind it. I didn't realise what they were going to do. They took cans of the Guinness out the fridge, poured it into the glasses, placed it into the mat and surged it. They pressed the button and it just made all that foam just rise to the top. And it looks like it's a special stuff. The Guinness I got was just standard Guinness, and this stuff just froths everywhere. The only way I could get the same effect was if I opened this and just left it in the fridge open, so it outgassed a bit. And it must just be down to the level of gas in it. So obviously I've had to test that quite a lot in the process of doing this. In fact, you know, before I do this, that would involve making it wet. So is this just going to pull apart now? But I saw them use that and I thought, oh, what on earth is that? And a little bit of research online showed it was a Guinness surger. Oh, that's not coming apart very well. Oh, blimey, spudger. Oh, that's sealed. That has been sealed as silicone or something. This could take a while. I'm going to give this a go, and if it doesn't open very quickly... oh, this is going to be messy. This is going to render this unit a complete mess by the time I'm finished with it. But then, better that I take mine apart than you take yours apart. Not that I'm thinking everybody has Guinness surgers at home. This is making a bit of a mess. But the seal is breaking. It does appear to be such silicone. Oh. Tricky. Let's get the fingernails into it and see if I can pull my fingernails off in the process. Nope, that is not easy. It's going to have to be spudger all the way. Right, tell you what. Oh, no, it's opening. Oh, there's an O-ring as well. Intriguing. Ooh. Right, is this thing... oh, there we go. Right, that'll do it. What have we got? We've got the control card. The power's coming in. It's going straight to a bridge rectifier and then a smoothing capacitor. There is a processor, but there's also... That's a bit odd. Let's see if we can get this out. It's all gooped in. Gonna have to be careful I don't destroy everything here. Why is that feeling strangely bouncy? Oh, it's the cable actually. Right. There are 2 integrated circuits. You know, even without using the magnifying glass, I can see the little 8-pin chip has got Guinness 2712 2WC. It's a custom program microcontroller, but what is that other chip? P274 Plus. P274 Plus. I'm guessing this is a microcontroller. There's a little LED which is shining through the bottom. There's a little crystal. Is this a 5-volt regulator? Oh, that might be a driver. There's the button input. There's the output. Oh, the output is being switched via, potentially, this transistor, if it is a transistor. I thought that was a voltage regulator at first. It may still be a voltage regulator. But the output will be switched to this little transformer, which is then going to boost the voltage up probably to the piezoelectric disc. Oh, it's a big ceramic disc, a piezoelectric disc on the back of this, which has the connections soldered to it, and then they've gooped over them to protect them. Can I get this out further? Let's open it further. So apparently if you put other drinks on them, like, oh, the screws, they all look standard, that's good. If you put other drinks on them, like, say for instance, if you put a full can of drink that's been unopened, and then you surge it, and then you open it, it apparently explodes everywhere. I'd like to try this. And if you surge other drinks, as you've seen, like cider, which are quite fizzy, then they just explode everywhere, just because the ultrasonic energy causes that mass cavitation of the fizziness. The transformer is huge. This is basically just designed to create a lot of ultrasonic energy over a brief period of time. I'm guessing if this thing tried running continually, it would very quickly heat up. Okay, that's not overly helpful. The rubber thing might pop out. Revealing the metal disc. Is the metal disc bonded directly onto that ultrasonic unit? Just going to be careful here that I don't pop the leads off the ultrasonic unit, because I do want to try experiment to this. It's fairly heavy. It's fairly heavy. And the ceramic disc is bonded really hard onto that to create the energy in it, the ultrasonic energy into this heavy metal plate. Very heavy, really strangely heavy. I wonder where all the weight is, if it's in the ceramic bit or if it's in the metal. But the metal feels quite heavy in its own right, even though it does look like it's just been pressed there. So it might, to a degree, be the weight of this ceramic here. Unless, oh no, because the ceramic's got a coating, the metallized coating on one side for that contact. The way a piezoelectric crystal works is if you've got the disc of crystal and you've got a connection on one side and a connection on the other, and you apply a voltage across it, it will distort. So what they do here is they apply an alternating voltage to this transformer, and it just makes it vibrate, but it can do so at extremely high frequencies. And to make this crystal, I believe, they initially put it in a heated chamber, and they bring it up to above its Curie point, and they apply a voltage across it. And when they do that, and then cool it down below its Curie point, it holds that charged state, which is the very nature of the piezoelectric crystal. So I'm looking at this chip over here and wonder what it's for. It's not obvious. Unless all the microcontroller is doing is gating this. But I thought the microcontroller would be generating the ultrasonic signal. I don't think there's feedback from this disc, is there? Nope, I don't think there is feedback. Oh, there might be feedback. Yes, there is feedback. Hold on, where's the notepad? It looks, to all intents and purposes, like the one connection is on the metal plate at the back, and it's connected to one leg of the capacitor. It's connected to the negative. I would also guess that the transformer output appears to be connected to, if this is the disc of piezoelectric material, it appears to be connected to there, and then the other one is connected to sort of that area. I thought this might have been a feedback winding, connection point to detect the flexing of the crystal, to make it oscillate at its resonant frequency. If this was a voltage regulator, I'd normally expect it to have quite thick tracks heading down to the microcontroller. The microcontroller is going to draw a lot of current. But I'm leaning towards the fact this transistor may actually be... Oh, I'm going to... One moment, please. I'm going to have to have a closer look at this. Okay, I've sussed what's going on here. This is a picture of one of these discs. It's commonly used in ultrasonic cleaning tanks. And I initially thought that the metal plate was one connection because it had a wire going onto it, which has come off, which is a bit annoying. I had to put another wire on its place. The old one wouldn't take soda for some reason. They must have the flux must have really oxidized the surface. But I thought that was one connection to the back of the plate, but it turns out, and this is probably why there's a good mass, it turns out that metal plate has another metal disc in the back of it, and that then this is then bonded onto, and they seem to be glued on with a sort of insulating layer. And I initially thought this was a feedback winding, but it's not. It turns out that the front plate is not connected in any way to the piezoelectric disc. The two connections that are onto this disc are onto this area here and this. And the clue is that if you look at the edge of this, you can see that it's got the conductive layer is actually going down the side and onto the other side of the disc. So this isn't a feedback winding. It looks like a feedback winding that you often get in piezoelectric discs, but in this case, it's actually going right round to the other side. So it is really just the two wires going onto this are one on either side of the disc. The circuitry breaks down like this. You've got the incoming supply, it goes through this fairly chunky bridge rectifier. Then it goes to this smoothing capacitor, and then the control circuitry. I've not elaborated on the control circuitry too much because there's this mysterious P274 Plus chip, which is 0618 written under it. It's a 16-pin chip. It doesn't correlate to being... I thought it might have been a 274 op-amp, but it's not. I don't know what that chip is. I don't know if that number actually gives any clues to its real function. Maybe it's a standard chip that I couldn't find, but I just didn't... I had a good long search, and I didn't find it. However, most of the work appears to be done by the microcontroller, and it does have the pinout that tallies up with the generic 8-pin microcontroller. You know, it could be a PIC 12 or something like that. It's got the crystal input for the timing reference, which is kind of important because these, if it's doing the driving, well, it is doing the driving, but if it's doing the driving of the piezoelectric disc, then they tend to run them at a very specific frequency. And it's got the button input, and it's got the output to drive the LED, and it's got the output to drive, and it's going direct to what I'm guessing is a MOSFET then. And the transformer, the little inductor, is a transformer. It's got the heavy winding in the primary, and then the lighter winding in the secondary, suggesting that it's probably boosting the voltage up to drive this, you know, at a much higher voltage, so it deflects more, which is quite a common technique. And that's fundamentally it. I haven't sussed what that mystery 16-pin chip is for. I also didn't find a dedicated voltage regulator. Either they're dividing the voltage down from the smooth supply via just a resistive divider, which would be not predictable really on basically an unregulated supply. Or it might be, and I'm suspicious that this might be the case, that this chip, the 16-pin chip, also has a voltage reference in it that was being used to also power the PIC microcontroller, keep its voltage rail at about 5 volts. So that is fundamentally it. Just one big transistor driving the transformer and a microcontroller really doing the bulk of the work, which is kind of what we expected, isn't it really? It's interesting to note that the disc is that type that's used in the cleaning tanks, but again, that also makes sense. It puts a lot of energy out, and I suppose ultimately it is the equivalent of basically putting Guinness into a cleaning tank and giving it a quick buzz, and the cavitation, the micro-cavitation, will create those tiny little bubbles that create the characteristic thick, creamy Guinness head, said Clive, sounding like an advert for Guinness. But yeah, that was interesting, and what's more, I think it might even work when I put it back together again, but time will tell. Other things worthy of note before I try this again and make a huge mess, because I'm going to try surging some, well, just what I've got handy, which is tonic water, which is very fizzy. That's a terrible idea. Things worthy of note, this is a little vent hole, but it's basically a recessed in, sort of inverted pillar into the unit, and it's got a piece of fabric just sort of bonded over the top of it. So it's designed to allow it to breathe, but not let liquid in, which obviously this is a wet environment. Likewise, the rubber seals around this are quite intense. You know, it really is supported well, partly for the ultrasonic effect in the rubber sandwich, but also to stop the water going down. So let's put a little drop of water in. It's notable that this thing actually came with text printed in it that said, you know, add 2 teaspoons of water to before using, and it's to help basically couple the ultrasonic energy across. Is this going to spill everywhere? Ooh. What was I saying there? I was yeah, the coupling energy and the spoons of water. The text had just, the first time I cleaned this, it just came off. That's working. Frothy. Though that's not too bad. It's not too fizzy. So yes, I put it together and it does appear to work. So that's a good result. So quite an interesting unit, I have to say. An interesting find. Oh, I should add, I got these on I got this on eBay. They've got a whole range, including the ones that mount on the front of the bar. It seems to be a fairly common thing, but being affiliated with the Guinness brand and for this particular function, it's quite, you know, a lot of them are commanding in the region of about £50 for these units. And certainly this one, I think I paid £50 for it, and even used ones were commanding high price. It just seems to be that sort of thing. And that said, if I go into my local supermarket, the only cans of Guinness I can find are not the ones specifically optimised for the Surger Guinness. They're the ones with the standard carbonation, so you have to let it settle before you'd actually do that. But if you wonder why do it, then my friends all said it was one of the best Guinnesses they'd had, which is interesting, because it had the right texture. It didn't have that coarse foaming top. It was that fine mousse that is characteristic of proper Guinness as served in Ireland. So, interesting stuff.